Assalamualaikum and hi. I am Siti Aisyah with student ID 16002445, and in this video we will discuss a problem for our assignment to Structured Programming and Database System. Our group consists of 4 members, which are Alya Hannani, Muhammad Syukri, Yunus Othman, and Siti Aisyah. First of all, problem statement. The Google company is an IT company that powers the search engine Google's used by Malaysians. Ahmad, as the electrical engineer at the company, was assigned to perform an analysis on the electric power usage of the data center. The electricity registration with TNB qualifies his data center as medium voltage general industrial tariff. The data center has computer servers, routers, firewalls, and an air conditioning system that requires 33,000 volts and 500 ampere of current to operate. Based on the data he gathered, he was required to make a statistical analysis on the data center's power usage and how it affects the monthly bill. This is the data that will be used for this program. First, we will include the library files that we'll be using, which include IO stream, include F stream, as we will be using the function of read from file and write into file. Then include CMAT, include iomanic, as we want the output to be in two decimal places, and lastly include vector. After that, we will declare variables such as integer I option, string month, double iterate, char count, and string dummy line. We will also declare if stream in file and of stream out file. After that, we will open the file. In file.open and the location of the file that we want to get the data from. Out file.open and the location of the file that we want the output to be displayed. Next, if not in file, the program will display error finding input file. The system will pause and exit. GetLine in file dummy line will be used in case 2 and case 3 to display header in the output. While not in file, .eof and I less than 12 means that the program will read the data as long as it is not end of file and it is still less than 12. Here we will be using do while loop and switch for the option. It consists of case 1, case 2, and case 3 corresponding to the menu operation here. Case 1, which is descriptive, will be explained by Syukri. Case 2, which is power usage limit, will be explained by Alya Hannani, and case 3, which is monthly bill, will be explained by Yunus later. At the end of the program, the user will be given an option whether to continue or not. If the user chooses yes, the program will go back to the menu operation, and if not, the program will stop. And lastly, we close both files, in file.close and out file.close.
Hi, I am Muhammad Syukri will explain about the first option menu, which is descriptive menu about statistical analysis. In this statistical analysis, we will do C++ program that will calculate the maximum value, minimum value, mean, standard deviation, median, and mode. Let's look in the C++ program. We will do two parts, which are for the electric power usage and total IT power usage. First, to find maximum value, we need to find the highest element. We declare float as high equal to electric at index 0. Then for integer I equal to 0, I less than 12, I equal to I plus 1. Then if the first element bigger than height, it will replace the height memory. Second, to find the minimum value, we need to find the lowest element. It is same with the maximum value, but we just need to change the symbol higher than to lower than. Next, to find mean, initially we declare sum equal to 0 using for loop. we added each element in electric to sum. Then we calculate the mean equal to sum divided by 12, which represents 12 months. Move on to calculate standard deviation. We must calculate the electric element minus mean, then power by 2 into array 2 variable. After that, we calculate sum from the previous calculation. Finally, to find the standard deviation, we square root the sum 2 that we calculate before. And lastly, to find mode, we need to do sorting first to find mode. Before that, we need to declare variable temporary, and we will do double loop like this. We start with the last index, which are index 11. If the value is higher compared with the previous value, it will replace into the temporary variable and so on until the sorting finish. To find mode, we need to declare count equal to 0 and mode equal to 0. It will display the mode if the same number repeated many times. Then for the IT power usage, we will use the same coding with the total electric power usage like previous one, but we need to change the variable from electric array to IT array. After that, we display the output of the statistical analysis for both power usage, which are electric power usage and IT power usage using out file. Let's look the output after we compile it. Uh, The output show the statistical analysis for total electric power usage and statistical analysis for total IT power usage in kilowatt hour. It shows the maximum value, minimum value, mean, standard deviation, median, and mode. Okay, that's all from me. Thank you.
Assalamualaikum and a very good day. My name is Alya Hannani Roslan, student ID 19001418, and today I will be explaining about the efficiency section in our case study. So for the efficiency part, there are two sections, which is power usage limit and power usage effectiveness, which is the PUE for a data center. So for power usage limit, it will notify the user if the power usage of the month exceeds the nominal optimum value for data center power usage, which is determined by the Energy Ministry, which is 317,100 kilowatt hour. So for power usage effectiveness, it is to determine how effective a data center is. So to calculate the PUE, the formula is total facility power usage over IT equipment power usage. So the categories are as below. For the PUE from 3.0 until less than 2.5, it is very inefficient. For 2.5 until less than 2.0, it's inefficient. For 2.0 until less than 1.5, it's average. For 1.5 until less than 1.2, it's efficient. And for less than 1.2 or equals to 1.2, it is very efficient. Next, moving on to the programming. So we have 4 library files that will be used here, which is the input output stream, the stream, vector, and input output manipulator files. So here we have 6 vectors that will be storing the data and 1 string dummy line that will be storing the header. So we have 12 for each vector, as in for each month. So we have a double power output vector, a string month vector, a string status vector for the power usage limit, a double IT output vector, a double power usage efficiency vector, and a string efficiency vector. So as usual, we open the file, and this line is to get the dummy line, which is the header in the text file. So here we store the data in the text file into the vector month, power output, and IT output. So for power usage limit, we use the selection. If power output I is bigger than 317,100, the status will be exceeded the nominal value, and if it isn't, the status will be within the nominal value. So for the efficiency part, firstly, we'll be finding the PUE, power usage efficiency, for each month. So the formula, as I mentioned before, is power output over IT output. So we test it for each element in the vector. And then we also will be using the if selection. So firstly, if the PUE is less than or equals to 1.2, it will be very efficient. PUE less than or equals to 1.5 will be efficient, and so on. So after we tested all of this, all the 12 elements as in this for loop, then we'll display the output, which will be displayed in the table form. So for cosmetic purposes, we use the set width 9 for the month and these vertical lines to make the table look more presentable, and this horizontal line. So we'll be displaying the month, the power output, the status, the power usage efficiency, and the efficiency. So we'll try running the program. So here is the output for this program. So we have month, power usage status, power usage efficiency, and efficiency. So the month, as we have set the set width to 9, here we have this. It is the default aligned to the right. Then we have power usage also with set width 9. So for example, for January, the power usage is 366,604. The power usage status will be exceeded the nominal value because it exceeds the value 317,100. Same goes to February and March. And then for the power usage efficiency, for January it's 1.38393, which is efficient. And for February it's 1.47561, which is still efficient. However, for March, it is a little bit high, which is 1.76108, and it falls under the category average. So this same goes to the other month. So that's it from me. Thank you.
For option 3, monthly bill. Monthly bill is sum up of main usage of electricity and additional payment due to power factor. For this option, there will be two parts. The first part is main usage of electricity. To calculate the total, we will use the formula as shown on the screen. From the formula, peak hour is the period between 8 am to 10 pm. Meanwhile, off-peak hour is the period between 10 pm to 8 am. For the second part, power factor. To calculate power factor, we will use the formula power used monthly divided by voltage time current. In this part, there will be three conditions. The first condition is if above 0.85, there will be no surcharge applied to the owner. Second condition, if between 0.85 and 0.75, the surcharge will be calculated using the formula shown on the screen. And for the last condition, if below 0.75, the surcharge will be calculated using the formula as shown on the screen. The result in a table will display payment due to main usage of electricity and power factor, value of monthly power factor, and the total.
Hi, Assalamualaikum. I'm Yunus Othman and my ID is 1800277. So I'm going to explain about case 3 for the coding. So as we read the input from the input file, and if you press number 3, which is a monthly bill, you will directly choose case 3. So for the case 3, we're going to calculate for electric bill without surcharge in RM. power factor surcharge in RM, and also total. Total is a sum of electric bill without surcharge and power factor surcharge. So in this part, this is the table. I do it. So this is the formula. T equal to 0.625 times the monthly electric use times the charge of PMB plus 0.375 times monthly use of power times the charge. So 0.625 we gain from 15 hours over 24, and 0.375 is coming from 9 over 24. So this formula is calculated based on the usage of power regarding the peak hour or off peak hour. So the next one, we to calculate the power factor surcharge, we need to convert the kilowatt per hour in here to watt only. So after we calculate, we calculate from kilowatt to watt. We need to calculate the power factor using the watt. So here the watt or the power in watt is divided in with voltage use and current use. So since the factory is a medium voltage factory, so the voltage supply is 33,000 voltage, and the current need for the by the appliances is 500 by 100 amperes. So next, in here we're going to evaluate the surcharge that will be applied based on the power factor calculated. If the power factor is between 0.75 and 0.85, uh, it will be charged 1.5% from the main usage of electricity. If it is below 0.75, then it will charge 3% from the monthly usage, and if it is other than that, the surcharge will not be applied. And here we will calculate the total. So the total is the surcharge due to the power factor and also the main usage. So in here we display the month, and also we display the main usage of electricity, the surcharge due to power factor, and also the total. So if we run this code, it will display this. So we type number 3 for the case or option 3, and it will display monthly bill menu is successfully run. So if we out from here and we open the output file, it will display this output. So here we got month, electric bill without surcharge, power surcharge, power factor, and also total, which is the sum of electric bill and also surcharge. So for the month we have January till December, and we have all this electric bill, power factor surcharge, and total in the RM. That's all for my part. Thank you.